this lesson we are going to look at a couple of things: undefined fractions, simplifying fractions, and multiplying and dividing. They're also considered rational expressions. Undefined fractions is where we will begin, and you will see that we simplify, we look at what makes a fraction undefined. It's important for later on in some later topics in the year. So a fraction is undefined when the denominator is 0. We don't care about the numerator. The denominator cannot be 0. So on the first example, this fraction would be undefined when x is 2, and you can just see that. On the second example, this one would be undefined when a or b equals 0. Sometimes, however, it's difficult to determine what makes a fraction undefined unless you factor the denominator. So on the third example, we factored the denominator, and then you would set each of those factors equal to 0 and solve. And you'd get y is 2 or y is 3. So that's what would make that fraction undefined. So a couple examples. The first one factors 2x minus 3, the denominator, and x plus 3. So if you set each of those equal to 0, you get that this fraction is undefined when x is 3 or negative 3. On the second example, same thing if you factor the denominator. So we're looking for two numbers that multiply to negative 14 that add to negative 5. So that could be negative 7 and positive 2. And when you set those equal to 0, then when x is equal to negative 2 and positive 7, this fraction will be undefined. Okay, now we're going to talk about simplifying. A couple of things you need to take a look at. If you have a numerator and denominator that are just kind of reversed with a minus sign in between them, they will simplify to negative 1. You can determine that by plugging in some numbers. Think 3 minus 4 over 4 minus 3. That would equal negative 1. You can also rewrite it as negative y plus x and factor out a negative 1. And then you'd have y minus x over y minus x, of which those cancel, and you're left with negative 1. If you have some numerators and denominators that are reversed, but the signs are both positive, that cancels to positive 1. And if they're identical, they simplify to positive 1 as well. You cannot simplify x plus y over x minus y. That does not cancel to anything. Okay? That is just equal to x plus y over x minus y. Does not simplify. Alright, so when you are asked to actually simplify a rational expression, and we will also take a look at the values that make it undefined, you should factor first, then cancel. Factor first, then cancel. You cannot just chop. You cannot just like cross out the x squareds. It doesn't work with regular numbers, so it will not work when you're dealing with variables. So the numerator can be GCF factored, that's x times x plus 3, and the denominator is x plus 3 times x minus 3. Now the x plus 3's cancel, and you are left with x over x minus 3. The values that make this fraction undefined, though, you have to look at the denominator before we actually simplified and canceled the x plus 3's. So this fraction will be undefined. We need to actually list the values for which the fractions are not defined. So x cannot be 3 or negative 3. That's what would make it undefined. Number 2, for this one, we can only factor the denominator. So that looks like GCF, so factor out a 2 and you're left with t minus s. So here's a situation where you've got the same numerator and denominator reversed with both a minus sign. Those cancel or simplify to -1. So this one, the answer is -1/2. What makes this undefined is if t were equal to s, because, you know, you'd have 3 minus 3, 4 minus 4, whatever number you put in there, 0 minus 0. So t cannot equal s, would make that undefined. Number 3, factor GCF, and then factor further that numerator using a difference of 2 perfect squares. And the denominator GCF, and then factor that further if possible. Now I need two numbers that multiply to 10 and add to 7, so 5 and 2. And then you need to look at what's going to make it undefined at this point before you cancel, and so x could not be -5 or -2. Even though we can cancel the x plus 5s, and this expression, and the 2's, simplifies to x minus 5 over x plus 2. Number 4, nothing can be done in the numerator at this point. The denominator is a difference of 2 perfect squares, a minus b times a plus b. And again, we see that we've got a reverse and minus signs in the numerator and denominator, so those cancel to -1. But before we do that, we cannot have a equal to b. So there's for our undefined portion. These cancel to -1. I always put the -1 in the numerator, and this simplifies to -1 over a plus b. Now on number 5, you just can simplify the x's. Some kids think that 3x divided by x is equal to 2x. It's not. It's equal to 3. All right, so that's simplifying. Let's go to the next page. Now we're going to look at multiplying and dividing. When you are multiplying and dividing, you just need to make sure you factor first. Cancel and then multiply anything that's remaining. You do not have to, you can leave it in factored form. When you divide fractions, remember you need to multiply by the reciprocal. Okay, so for number 5, let's start by factoring this. So then we have to look at the values that would make it not defined as well. So when we factor this, it would be GCF 3x times 2 minus x, and then in the denominator it's x times 9x squared minus 1. That's 2. I see some further factoring, so 3x, 2 minus x, and then a difference of perfect squares, 3x minus 1 and 3x plus 1. You see, you've got a difference, and every term in the binomial is a perfect square. I'm going to multiply by the reciprocal, so I'm going to be placing the x squared minus 4 in the bottom, and the 3x squared plus 5x minus 2 in the top. And when we factor the denominator, that's x minus 2 times x plus 2, difference of perfect squares. And then the numerator is that trinomial factoring where the leading coefficient is larger than 1. So you may have a couple methods. The one I like to use is first terms, 3x and x, and the last terms. So the last terms have to either go 1 and 2 or 2 and 1, because they have to multiply to -2. Now I'm looking for ways that I can place the 1 and the 2 so that when I multiply and then add together the outers and the inners, they equal 5x. So if I put the 2 out here, then that would give me 6. And if I put the 1 here, I could subtract to get 5. So if I do a positive 2, that gives me positive 6, and if I do a negative 1 here, that gives me negative 1. 6 minus 1 is equal to 5. Now at this point, the undefineds are, I could not have x be 0, I could not have x be 1/3, so there's lots of undefineds. So x cannot be 0, plus or minus 1/3, plus or minus 2. Quite a few things. You should probably look at what makes that entire undefined fraction before you do the simplifying. And then 3x minus 1, x plus 2, the x's cancel, and remember the x minus 2 and the 2 minus x simplify to negative 1. So looks like we are left with negative 3 over 3x plus 1. All right, for number 6, we're going to flip this around. So it's 8m cubed divided by 3 times, oops. Okay, so then we have 3m minus 12 over 6m cubed. So we can factor the 3m minus 12. Make my pen a little smaller. 2m minus 4, and then we are ready to do some simplifying. So the 3's, the m cubes, these are like multiplied, so the 8 and the 6 can simplify. 8 divided by 2, 6 divided by 2, and I believe that's it. So 4 times m minus 4 all over 3. Now, you might think there's nothing undefined, but there is. We cannot have m equal to 0, because you have to look at it before you simplify. And then let's take a look at number 7. So that's a bit of a longer one. So I'm going to start right away with simplifying 2, and you're left with x squared minus 1, GCF factoring. And then here's one of those trinomial ones with a leading coefficient greater than 1. So I look at 2x and x, and I need to have, it has to be 1 and 1, there's no choice. And then the sign's positive here at the end, and then it kind of points back to the middle sign, which is negative, so these both have to be negative. So you have to multiply to positive 1, and when you do the outers and the inners, they have to add negative 1x, negative 2x to negative 3x. Multiply, actually there's more factoring over here. 2 times x minus 1, and x plus 1, and 2x minus 1, and x minus 1. And this one we need to flip around, so x squared plus x minus 6 comes up to the top, and x squared plus 7x plus 12 to the denominator. So when we factor that, we have two numbers that multiply to negative 6 and add to 1. It's not the same as the leading coefficient greater than 1, so I would be looking at 3 and 2. Positive 3, negative 2. They have to multiply to negative 6, add to 1. And then on the denominator, I need two numbers that multiply to 12 that add to 7. So plus 4 and plus 3. And then for the next one, this is difference of two perfect squares. Notice difference 2, and they're all perfect squares. And then we have a trinomial again, so we've got 2x and x. Now, I can put the 2 here or here. If I put the 2, in the first set of parentheses, then that gives me a GCF here. There's no GCF in the original problem, so I shouldn't have one in either of the parentheses. So I'm going to put the 2 at the end, the 1 in the middle, And I need those two, when I multiply 4, when I add them to 1x, they need to equal negative 3x, so this has to be negative and that positive. Now negative 4 plus 1 equals negative 3x. So I'm just going to rewrite that. I think I've factored everything completely. I'm going to look at my undefines, okay, because all of my denominators, so it looks like x cannot be 1/2, x cannot be 1, x cannot be negative 4, negative 3, negative 1/2, or 2, okay? So now I'm ready to cancel. So 2x minus 1, and way over there, those simplify. X minus 1's right away in the first fraction. 2x plus 1's here. X plus 3's. X minus 2's. Looking around, I don't believe that there's anything else, so final answer is 2 times x plus 1 all over x plus 4. And there you have it. Let's do one more, number 8. So when you see something with the squared term, you cannot just distribute that through, you have to write that out twice. That denominator will factor to two numbers that multiply to 7, negative 7 and add to negative 6, so 7 and 1, negative 7 and positive 1, and then a GCF, and a difference of perfect squares. Okay, so look for the undefines. X cannot be negative 1, 7, or negative 7. And then cancel away. Now, if you've got two of the same factors in the denominator, they do not simplify. It has to be one from the numerator and one from the denominator. So the x minus 7's go, the x plus 1's. Looks like your final answer is 5 over x plus 7. Okay, so now it is your turn to try number 9 and 10. Complete the notes, and we'll see how you did tomorrow in class. Thanks.